cache, right? So in web cache, so web cache is this again is something that we need for this HTTP access of the web servers and all that, right? Because it reduces the time that is required to get the object, right? So web cache, or we also call it proxy servers, right? So it's the same thing. So web cache or proxy servers, okay? Oops, proxy servers. So internet is densely populated with web caches. Okay, so we'll see why do we need it. What's the advantage of this quickly, right? So at one, we'll start the lab discussion on lab module. Okay, so for example, if there is a web cache in between my request to the original server, this is also known as proxy server. So this server will act as a client as well as server, right? This will act as a client as well as server. So the very first time the client sends a request, it goes to a proxy server or web cache. If the web cache has the requested page, it will return, because this is the very first time the web cache has not uh, the requested object or the page with it. So it will forward the request to the original server, say google.com. It will receive a response, will keep a copy of the web page, right, in its cache, and will forward the HTTP response to the client. Let's say there is another client who wants to access the same page. The request again will go through web cache, but this time the web cache or the proxy server has the cached copy of the same web page. So now the request will not be forwarded to the original server. And if we say there are hundreds of such clients accessing the same, the web page, so all these hundreds of requests will not be forwarded outside the network and will be taken care of by this proxy of server web cache. So it's a server in this case, right? Because in the second case, because it is providing the requested page, and in this case, it is acting as a client. Where, in case of not having the requested object cached, the request will be forwarded to the original server. Okay, very very important. The internet is densely populated with web cache. Why it is important? We'll see, right? So when we send a request to the original server and we receive the web objects. So the original server can exactly control which object can be cached and which object cannot be cached. For example, we can have this cache control field in the header line or the response headers. Okay, and we can specify the maximum age in seconds. I mean, for 180 seconds, for example, this object can be cached. Okay, after that, this object will should not be cached. Okay, so I can say, okay, this object cannot be cached, so cache is not allowed. So we can explicitly control. I mean, the original server, while sending the objects, can explicitly control the length of the cache. I mean, for how long we can cache an object in the proxy server or the web server, or the web cache, sorry, and or whether the proxy server, the web cache, is allowed to cache an object or not. Okay. Why web caching is reduced? Let me try to explain this with the help of a scenario, right? One obvious reason is to reduce the amount of traffic that we are sending outside the institution on institution's link, right? But let me explain this with the uh, help of scenario. But this point is very important, right? This is very very important. So internet is densely populated with cache. Okay, and we have all these CDNs, content delivery or distribution networks, used by Netflix, Google, right? And uh, for example, Meta. Okay, yes, too. Okay, but what about the poor content providers, right? Not having their own data centers, their own CDN servers to be placed near us, right? For such content providers, this cache is very very important to effectively deliver their content. Okay, we'll see how. So let me explain to you the importance of web cache with the help of this scenario. So first of all, you need to understand this scenario, right? So in this is our institutional network. Okay, so here we have this institutional network, and the speed within the institutional network is 1 gigabits per second, right? So when a machine sends data to the router or to the other machines inside this network, the speed is 1 gigabits per second in this LAN. Okay, and when the request is sent outside the network, the speed is 1.54 megabits per second. So over the internet, there are different origin servers, original servers that I want to access to. Okay, and RTT from institutional router to the server is 2 seconds. So if a request is sent from this to a server and I receive a response, it takes 2 seconds. Okay, this is another thing that is known to me, right? So तीन चीजें होगी. And then the web object size. So when I request this and receive different web object, the size of the web object is 100 kilobits. Okay, and the average request rate from the browser to origin, I am making 15 such requests every seconds. Just know. And the
Yes, sir.
average data rate to
Yes,
browser
sir.
is 1.5. And the average data rate is of a browser is 1.50 megabits per second. How many requests we are sending in 1 second? 15 requests. Yes, no? What is the size of each
Yes.
request? 100K, right? Okay. So this comes out to
Yes,
be
sir.
1500, which is 1.50 megabits per second. So how many number of requests are being sent? देखिए. Okay. And what is the size of the request? So I can use this to get the rate. So now we can look at the performance of the network. If this is the case, that the case is that by any machine, the average data rate is 1.50 megabits per second, and the output length is 1.54 megabits per second. The access link utilization is 0.97 divided by, okay,
1.5.
1.54. But this gives me what? We get this. This is by dividing the average data rate by the length, okay, which is 0.54. This comes out to be, okay. This is my average data rate. This is my outgoing link rate. Okay. So this tells us the intensity of the network, right? Traffic intensity diagram representing traffic intensity, right? So this the the closer the traffic intensity is to one, this means what? This will result into longer queues because I am approaching the maximum limit. Okay, so we have learned this. The intensity closer to one means what? Longer queuing delays means high utilization. Okay, whereas the land utilization is what? 0.0015. Will divide 1.5 by 1 giga. 1.5 into 10 raised to power 6 divided by 1.1 into 1 into 10 raised to power 9. Okay, the answer is 0.0015. So this is very good as far as the land utilization is concerned. Why? Because it is closer to it. We are somewhere here. I mean, this means you know less queuing delays, low queuing delay. Okay, and if I want to calculate the end-to-end delay, So this can be a sum of these. So we have this internet delay, which is what, right, where we make a request to the server and we receive a response. This is the RTT, right? Round trip time, 2 seconds. Plus, we have access link delay. This is the problem here, access link delay, because if all the machines are sending, and this can be in minutes, okay. And then we have LAN, which is some microseconds, LAN delay, which is this, right? Okay, so this means I have my limited access link rate, which is 1.54 megabytes per second. And if I keep on sending, increasing this rate, and imagine that this is being sent by all, the server, this can create a problem, right? So if I want to improve this, if I want to minimize this, what are the options? What are the options that I have? One simple option is I need to increase the access length. Okay, I need to increase it from 1.54 megabytes per second to 154 megabytes per second. But this is costly. This will cost me, right? I have to pay for the bandwidth, extra bandwidth, right? And if I do this, yes, it will, the intensity or the link utilization will be 0.0097, which means, right, on my this graph, I'm here somewhere, okay, which is fine. But this involves a lot of cost, right? I have to invest in terms of bandwidth. There is another option, right? And obviously, yes, this can go to this access link delay can will be in milliseconds. But there's another option here. What if I install a local web cache here? Okay, it was not there. Okay, the rest of the scenario is the same. Okay, so now, and there's one thing that I have to make an assumption about is the uh, hit rate or miss rate in a cache, right? Okay, so um, so let's say the cache hit rate is zero point 0.4. Zero point 0.4 means what? 40% of the request will be served by the cache. So when I send a request, the request is first, goes to this cache. If the page is available, the cache will return me the page, or otherwise, the request will be forwarded to the origin server. So I'm assuming that 0.4%, I mean 40% of the cache hit rate is zero point 0.4, or the 40% of it, the requests are served by the cache. And this means 40% of the requests are with few milliseconds delay, and even less than that, right? Yes, no. And we can recalculate everything, and this means if rate is 0.4%, this means 60% of the requests are being sent to the origin server. So can you calculate the browser rate now? Yes, it was previously what? Do you remember? Okay, 1.5 megabytes per second. And now we are not sending this whole 1 megabits per second out of the access link, because we are sending only 60% of such requests. So I'll multiply it with point the miss ratio, which is zero point 0.6. Okay, and now the rate has decreased to zero point 0.9 megabits per second. There we go. All right. We had this entry in the HTTP response, if modified since. So when a web cache is recording or storing an object, right? It also stores the date. Yeah. For example, I'm storing a page, a web object here. I will also add the date, right? When this page was stored. Okay. This is very, very important, right? So the client specifies when client requests the same web object from the same server, it adds the date. It asks the web server whether the web object has modified since this date. I mean, the date when it was stored in the cache or the proxy server. For that, we have this field name if modified since, which includes the date. Okay. And if it is not modified, the server will send me a response 304, right? Remember, from 304 to 399 are redirection and all that, right? So it says 304 means not modified, and it will not send the object in this case because the object is already there with the proxy server or web cache. So let me try to explain this with the help of this example. So client sends a request, right? And add this tag, header field and the value, if modified since. And server, after looking at the value, if it finds that the object has not been modified, right, it will send a response which is 304 means not modified, and it will not send the requested object. And if again I send a requester after some time and the object has been modified since that date, so now the response is http 1 dot, 200. Okay, means this time the data will be the object will be sent in the data field. Here we will not send the object, right? So we will not send the object. It will include no data whatsoever.